Well, good afternoon, ladies and gentlemen. My name is Tony Goodhew. I'd like to thank you all for managing to find the room after the room changes. And that, unfortunately, they didn't find my slide deck. So we'll just be going with this one. I'm sure you've been to a number of the other sessions. You've seen the front-end TechEd slides and the back-end TechEd slides where they tell you have to go and do the assessment, the evaluations, all that sort of thing, that in the event of fire, leave this way and that way. So we'll just assume those have already been done, and we'll just get cracking into the session here. Just get that out of the road. This session is Dev 270. It is a Windows XP Service Pack 2, a developer overview. The aim of this session is to give you a bit of an overview, a bit of a look and feel at the major things that we're doing in Windows XP Service Pack 2. What we're going to do is go through the session. We'll look at each of the 4 major buckets of changes. I have some demo code that we'll go through that'll show us exercising those 4 major areas. And then hopefully we'll finish up. We'll take a little bit of time to discuss or answer any questions. Also following this session later on in the week is Dev 370, which is a more in-depth view of these changes. John Box and Dan Fox will be going through each of the 4 buckets. They'll actually be walking through the code. They'll be showing you a lot of the changes. Now, the demos that I'm going to show you today are in C++. The demos that John and Dan are going to show you are going to be in a mix of C# and Visual Basic. So we have sample code from either of our 2 sessions, irrespective of the language that you use as a developer. You'll be able to go and get that sample code and see how to exercise all of the features inside Service Pack 2. So over the past 2 years, we've really been looking at how these issues around security have been affecting the Windows XP platform and Windows platform as a whole. One of the things we're seeing is a dramatic increase in the number of exploits. In fact, if you look at the software industry in general, what you can see is that over the last 10 years, there's been almost a 50-fold increase in the number of exploits that CERT has gone and placed advisories on, irrespective of the actual platform upon which the software is built or the languages that they're built in. We're also seeing the time to exploit decrease. One of the interesting statistics that we've noticed over the past couple of years with regards to Windows is the approach that people who want to exploit Windows have been taking with regard to our security advisories and patches. An example, the NIMDA worm that went out, from the time we actually released an advisory and a patch describing what the problem was, here is the fix, here's how the fix could be exploited, or here's how the problem could be exploited. It was 331 days before somebody actually coded up an exploit and released that into the wild. In the recent case of Blaster, from the time we released the patch and explained what the problem was to when an exploit was in the wild was 25 days. The Sasa worm that just recently went around, from the time we released the patch and explained what the problem was to the time there was an exploit in the wild was 11 days. We're seeing the time from when we actually release a patch to when there's an exploit available decreasing. And this is these malicious writers or software developers are releasing these these exploits and taking advantage of the fact that customers are somewhat constrained in how they can roll out patches, how they keep their systems updated. We're also seeing the exploits become more and more sophisticated. Gone are the simple things of just looking at a port and sending a malformed packet to the port and causing the system to terminate or to crash. Now people are taking control of the system. They're actually using those things either in distributed denial of service attacks, or what's worse, the new ongoing trade of selling proxied machines for use in mass spam campaigns. There was a very interesting article written about how the hacker or the spammer community actually sells lists of machines that have been compromised and can be used as spam engines, and does a roaring trade in trying to get viruses, to get these pieces of malicious code onto users' machines so they can take control of this machine and use it as part of their spamming network. Looking at all these things together, the difficulty customers have to patch, the time the exploits are coming out in, we realized that the approach that we're taking, patching a problem on a time as it appears, getting that patch out, telling customers, working to gradually improve the underlying security of the platform, that approach simply wasn't sufficient. We weren't delivering the type of security that you as customers depend or demand from us in the underlying platform. And so we had to do something to fix this. When we looked at all the different things we could do, we realized that there simply wasn't a silver bullet. There was no little magic switch, that go into the registry database in HKey local machine / make my system secure. We could turn that on and suddenly everything would run and be secure. What we realized is that the problem is complex, and it's complex from an administration perspective. It's complex from a software development perspective. An interesting little statistic, when we hire our developers now, in fact, since we announced our Trustworthy Computing initiative, on a new hire, a developer comes in and does, I think it's a month of security training. They go through how to write secure code, what are the issues they need to consider. But when we bring these guys on, we've got to try and get across to them that security is a complex problem. So we ask our devs when we hire them, do you know how to write secure code? Almost 100% of developers say, yes, I know how to write secure code. Yet we give them a test. Only 29% of them can pass the test on writing secure code. And the reason is not because they don't know. The reason is because security is far more complex than what they think it is. For example, a developer can sit there and say, oh, I always check the length of my buffers. I always make sure that input that I get goes through a regular expression check before I use it. That's fine. You check for buffer overruns. You check for malformed input. What about heap exploits? What about integer underflows? What about all the other things? Cross-domain scripting? What about SQL injection? You're not checking for all these other things. So, you really aren't thinking about security in a holistic sense. So we wanted to look at how we could make the platform more secure, and we realized that we had to go and take a much more aggressive approach to delivering a secure platform. So with Windows XP Service Pack 2, what we've done is to go and make some fundamental changes, not only in the API set, but in the defaults and how we actually install the product to start with. The firewall in Windows XP Service Pack 2 is on by default. If you had the firewall turned on, if you had used Internet Connection Firewall in a home machine, none of those exploits that I showed you on the previous slide would have affected your machine just by turning that firewall on. Sure, there still would have been other exploits that could have affected you, but just those big ones wouldn't have affected you. So we're going to turn that on. We're taking all of the outstanding fixes that exist, whether they're QFEs, whether they're security fixes, whether they're customer requests. All of those are being bundled into SP2. We're changing the way users will experience email and web browsing. We're going to make that experience for customers a safer and a more private experience so that they can rely on Windows XP as a platform upon which to send email and to go and browse the web. And finally, we want to take advantage of some of the new hardware that's coming out. Things like the AMD Athlon 64 with its non-execute or NX protection, Transmeta or Intel, VIA, all shipping or planning to ship in the next sort of 6 months, CPUs that now provide a level of hardware protection to assist you in defending against buffer overruns. So we're taking all of that and moving that into into Service Pack 2. You can characterize Service Pack 2 really as 4 major areas. The first is network. Changes that we're making to help protect the system from attacks over the network. What that means is I've got my machine here. Network, you can think of the attacks out here. It's trying to come into the machine. So changes that we're making to protect from that external attack. Changes in email and instant messaging are about helping the user protect the system once the payload is already on the system. Somebody has sent me this wonderful picture of Anna Kournikova. How do I ensure that my machine actually is far more resilient to that type of attack? The web bucket is about changing the browser experience so that I can go to websites and I don't have to worry about malicious websites downloading code or taking over control of my machine. And finally, the memory changes are about that hardware protection, about some fundamental changes we've made in the compilation options that we use to build the OS. We now include the /GS flag. What that does is part of the Visual C++ 7.0 compiler now goes and provides stack cookie protection throughout all of the binaries or the majority of the binaries in the Windows platform, so that we can help protect from buffer overruns. So what I'd like to do now is actually go through each of these boxes. We'll talk a bit about what's going on, what we're doing in each of these individual boxes. We'll have some demos and have a look at what that actually means as far as you as a developer. First thing that we're doing, probably one of the biggest changes that you as developers will see, is that we're turning on the Windows firewall. When a user goes and installs SP2 on their machine, they will be prompted with a big screen that says, hey, you should turn the Windows firewall on. And we'll be directing users that the safe thing for them to do is to turn this firewall on. What this does is offer increased protection from external attacks. It's a stateful firewall, so it should have little impact on outgoing applications, but it will stop you if you have an application that is sitting there trying to listen to a port. What we've done in the Windows firewall is to go and extend it so that it's far more configurable. One of the biggest complaints that we had about the Internet Connection Firewall from the corporate developer was that it simply wasn't capable of being configured and manipulated. So now it's fully supported by a series of group policy objects. So you as IT professionals can go and configure how the application, how the firewall will work, and deploy that to your desktop utilizing group policy. We also have a set of command line options and some extensions to the net command that enables you to actually go from the command line and configure the firewall. We also wanted to make the user interface simpler. In the Internet Connection Firewall, we presented the user with this complex interface. We required the user to understand, is this network app or is this network port UDP or TCP based? What's the port number? Is it inbound, outbound, send, receive, a mix of those? Often it was very, very difficult for the user to go and configure that and understand what the change was that they were making. So a lot of users and a lot of ISP support departments would simply go in and tell their customers, oh, turn the firewall off. That's the easiest solution. Rather than walk you through how to configure it and deal with all that, they just turn it off. Unfortunately, that defeats the purpose of having the firewall in the system. So in the Windows firewall as part of SP2, we've made the UI much simpler. The user will get prompted. It'll have a friendly name. It will say things like, Windows Messenger is asking for access to this port. Do you want to let it do this? And you'll be able to have a much more guided experience for your users so that they won't be inclined to turn the firewall off. We also identified a potential security flaw in the Internet Connection Firewall. The Internet Connection Firewall had a dependency upon the network stack. And so what would happen is that it would wait until the full network stack was loaded before the firewall would bind itself to the stack and start defending the machine. The problem with that was that during that boot process, it was theoretically possible that at some point before the firewall was loaded and started, that the machine would have a valid network address and could be attackable. What we do now is as soon as that network card is enabled and the network address exists, we load the firewall with what we refer to as a static boot time profile. That boot time profile effectively disables everything. It says, no ports are open except for the minimum amount of ports required for the computer to boot correctly, such as DNS and DHCP. Once the system is booted and the stack is fully loaded, then we actually go back in and read that first profile, bring that up into the firewall manager, and start protecting based on what you've set your machine for at that point. We also wanted to address one of the new attack vectors that IT professionals are concerned about, and that's the mobile user. When I have a laptop connected to my corporate network, I have a firewall running, I'm on the corporate network, I have corporate applications, so I may need special ports open to go and talk to SAP or to Oracle, or to some CRM system. And then once I've got those open, what they're concerned about in the mobile case is I grab my laptop and I walk down to Starbucks and I turn it on, and now I'm connected to the wireless internet, through a wireless network, to the internet with no firewall, and I'm available to have somebody come in, push some malicious content on a machine, then I'm going to bring that back into the corporate network. I'm going to plug it in, and again, this payload will now be behind those firewall barriers. So what the IT professional wants to be able to do is to say, okay, I'm going to set up one profile for the Windows firewall for when I'm connected to a domain. I'm going to set up another profile for when that machine is off a domain. So for example, at Microsoft, what we have is we have a profile set up that has a series of applications pre-registered for SP2 internally. When one of our users takes their notebook off and goes to Starbucks, the actual firewall profile is the roaming profile, and it has no ports enabled on it whatsoever. So that user is not able to, will have full firewall protection, and that machine will have this ability to be safer in an external environment that isn't managed by our own IT group. The last thing we did that we really wanted to do to make Windows Firewall more usable in the home networking area was to deal with the file and print issue. For those of you that tried ICF in a workgroup a scenario or in a home networking scenario, know that it wasn't terribly easy to configure. You turn on ICF and suddenly you couldn't talk from one machine to another. You couldn't share the printer. And then there was this list of steps that you would have to go through. You'd have to go through and open this port up, give this access, so that you could have networking. Again, most home users would turn it on, suddenly stop being able to print their digital photos to their printer, would simply turn that off. Now what we've done is integrated the Windows Firewall with the actual network setup wizard. So when you install the machine and run the network setup wizard to set up your home network, we will actually ask the user whether or not you would like file and print sharing set up for the Windows Firewall. And we'll actually go and set that up automatically for them. Additionally, we extended the firewall to have the concept of scope, where what it would do is it would say, okay, I'm only going to accept TCP packets from a particular IP subnet. So most users in the home networking scenario are sitting behind a NAT device, and they are existing in the 192.168.1.x sort of subnet space. What we can do is the firewall can open ports up, but look at the packet coming in and saying, okay, I'm going to open file and print share up, but if I get a packet that comes from a different IP address in the subnet, I'll just throw that away completely. So what does all that mean for you as developers? Well, inbound network connections, if the applications that you write depend on inbound network connections, then you are going to have to configure the Windows Firewall. Fortunately, the Windows Firewall has a rich set of APIs that you can utilize in your applications to dynamically configure the firewall, either at install time or while your application is running, so that your app can go and utilize ports. You should, and our recommendation is you should build your app not to open these static ports, but to dynamically talk to the firewall and say, hey, open this port up. I want to talk to that port. And then have that port open, and your app does its work. Then at the end of that, shut that port off, and the port will close in the firewall, so that the port is only open and bound to your app during the period that you actually run. So let's have a look at the Windows Firewall. Okay, let's not do that. Let's do this. Okay. Okay, who knows? That's what we refer to as a UUMW, or an unexplained, unreproducible momentary weirdness. Okay. Okay, this is just a small C++ application, and basically what I'm doing is going and utilizing the COM interfaces that will go and manipulate the underlying firewall. As I said, in Dev 370, they're going to show you this exercise in its exact same functionality, and they'll do the demos in VB and some of the other demos in C#. If you want to get access to this, these header files and libraries, you can do so by getting the latest release candidate for the platform SDK. If you go to http://msdn.microsoft.com/security, they'll take you to a link that allows you to download the release candidate 1 of the platform SDK for Windows XP Service Pack 2. That'll give you all these header files. So what I'm going to do is just actually run this application. And we'll just run through again. So the first step, once you have your app running, you've written your application, you want to start manipulating the firewall, is you're going to go in and actually create a class of the Network Firewall Manager. Basically, the Firewall Manager is the root class, and it enables you to manipulate things like the policy, the profiles, the ports, the application whitelists, and so on. So you go through and you instantiate a member of that class, and then you start working on that to actually get access to the firewall. You can do things such as turning the firewall off. So in this particular case, I'm going to call a method on the profile and ask it to turn the firewall off. So if we just step over that method, we can step into it, and you can see that we're going to go check the firewall, see if it's on. If it's on, then we'll turn it off. And then at the end of it, we'll actually just exit out. So let me just go back down to and we'll just run this again. That's a bit further. So what you can see here is down in the bottom right-hand corner of your screen. When you turn the firewall off, we're going to prompt the user. We're going to show the user the status of their system. So you'll get this balloon tip that will show up that says, hey, the firewall's off, or there's some issue with it. In fact, I don't know if you've seen the new UI, but this is the new Security Center. And this is a item that's in the control panel that users can go to get an idea of what the status of the security aspects of their system are. And you can see here that now we have this firewall turned off. What I'm going to go do is use the same method again, but this time I'm going to pass it a true and say turn the firewall on. So if we run to that point, and you can see that we're calling the enable the firewall. So we'll run through. And now you can notice that the balloon's gone away and the little security shield is missing. If we go and have a look at the security center, dynamically the security center is watching the status of the system. I can say, hey, the firewall is now turned on. We're all safe. So the next thing I'm going to do is show you how you can add an application to the firewall. You want to run your apps and dynamically talk to the firewall so that you can add yourself to that app. In this particular case, what we're going to do is add Windows Messenger to the application. And you can see what I'm doing here is saying, okay, here is the actual executable I want to add, and here is a friendly name that I'm going to give that. So let's step through there. And if we go here and have a look at Windows Firewall, we can go and have a look at the exceptions tag, and you can see I've now added the Windows Messenger application to the whitelist. So you can dynamically add your app to the whitelist and configure yourself to actually have an exception in the ports that are blocking. We can do the same thing for a particular port as well. In this particular case, I want to open up port 80, and I want to share it for my web server. And so if I go back to the Security Center, I call the APIs to go and add myself. Whoops. And if we have a look at the exceptions, you can now see that I've added the web server port. And if we actually have a look at that entry, you can see the port specified, TCP, it's got a name and a protocol and a port number. So it's very easy for you to go and add yourself dynamically. I open that port up, I go to the whitelist, add my application, I start communicating through the firewall. So you can go and add all of those bits to your applications to work seamlessly behind the actual Windows firewall. So let me just run that out, and we'll switch back to our PowerPoint machine. And now we'll talk about some of the DCOM and some of the RPC changes. We've done a series of work in terms of reducing the DCOM and RPC attack surface exposed. We've turned off a number of servers. We've changed some basic things. For example, we now require you to authenticate on default interfaces. Previously, you were able to go and query for an unknown, get a query interface to that, and start working on it without actually authenticating. Now you have to go do that authentication to get that interface. We also have a programmatic ability now for you to go and configure RPC and DCOM for the local machine only. What you can do is call this API as part of your RPC server code. What it will do is say this RPC endpoint is only available from the local machine. So for example, if you have an RPC that you want to call out and back in again to that particular machine, you don't want to make that available and have anyone on the network actually go call that. You can go in and configure the launch permissions for DCOM through the registry. We've now implemented the concept of limits. We have limits, we have machine defaults, we have custom security and then machine defaults. So you can go through and say, I'm going to set the limits for my machine, which is sort of the gatekeeper of access to DCOM. So I never want to see access from these particular, from accounts other than these particular accounts. I only want to let that go through to my objects to start instantiating them. What we've done is move most of the actual subsystem code for RPC into a lower privilege. We used to run RPCSS as local system. Local system is a very high privilege account in Windows. So if you were able to exploit RPCSS, you would have local system account to an entire machine. What we've done now is move RPCSS down to network service so that it's now in a lower privilege account when it runs on the machine. We're also giving you the ability to control how authentication is done on your endpoints of your RPCs and DCOM calls. What this means to you as a developer is really three things. First, you need to, where appropriate, call that API. If you write RPC code or if you use remote procedure calls, call that API and say, I only work on the local machine. That will give you a sense of, that will give you a implementation of security because only code on that machine will be able to execute your RPCs. Don't use anonymous clients. There are very good reasons for using anonymous clients, and in fact, I'm going to demo to you how to set up anonymous client work in a workgroup scenario because a lot of people have written home networking software built around this concept, but ideally, you should always use authenticated DCOM calls. If you're in a domain, you'll use NTLM authentication, and it will be very, very easy for you to do that authentication from component to component. If you're not in a domain, you really should go and use an authenticated contact. The thing to remember about authenticated DCOM is that in Windows XP, we removed the guest account from everyone. So the everyone group on Windows XP no longer includes guest as a member, and we have a registry database option called force guest, where if you set that, then any access that is not a member of that machine will in fact be forced as guest. So you'll have to add guest. Ideally, you should turn force guest off and then create local accounts for all the external DCOM access that you actually want to do. Finally, UDP is a very easily spoofable protocol because it's connectionless. So we are turning off the ability for you to use UDP as a protocol for RPC, so you should not do that in your applications. So what I want to do now is show you a very quick demo of how you would set up anonymous DCOM access in a workgroup. The reason I'm showing you this is you can imagine the home networking scenario. You're an ISV, you want to write a utility that would be attractive in the home market. A common request in the home market is I have one scanner. I want to share it to my machine, to my wife's machine, to say a notebook. Well, the way I might do that as a software developer to write an app in that area is I'm going to write a DCOM server that runs on the machine with the scanner. I'm going to surface that out to all the other machines that are in my home network that are not domain authenticated, that are just a member of the same work group. And so these things I'm going to want to have talk back and forwards. Well, a lot of times you'd want to use an anonymous login for that prior to these changes. So what I want to show you is how you would enable that in this type of system. You really should move to that authenticated model, but the XP SP2 has been designed to be pretty straightforward in terms of enabling you to set up applications so that they work successfully on machines without changing. So what I'm going to do is over on the left-hand screen here, what we have, or your right, is an application which is a DCOM client. Basically, it calls a little DCOM server that's going to be running on this machine here, which is on the right-hand screen here. So we'll just wait for that to fire up. I don't need to share that. I do, however, want to show you the task manager because you can notice the components running. So the component is this component that I have here called DCOM server. And when I go through my code on the left-hand page here, I'm going to run this. And we'll just step over that code create instance. What I'm doing in the code create instance is basically I'm asking the machine, I'm asking DCOM to instantiate a copy of that object. Now, what's going on here is I've called out to the network, and I'm asking the network, I'm saying, hey, I want to go to my VPC here, and I want to open this port up. Well, I haven't touched the firewall on this machine. So you can imagine in the home situation, I've just installed SP2 on this machine here. And so what comes back is this error, and I'm sorry this is down the bottom here, for those of you over on this side. Actually, we can show you here. What you see in the error is you'll get back an error saying this RPC server is unavailable. This is nature's way of telling you one of two things. You either got the machine name wrong and the machine doesn't exist on the system, or the firewall is enabled and stopping you from actually getting to that particular RPC port. So what I'm going to go do is go over to this machine here, and what I need to do is go into my control panel, and we'll just wait for this to boot up. And it's working. We'll open up the security panel. So this is a VPC, this is a virtual PC image running on this machine. I'd like to point out this is not the native speed of XP/SP2. Though in one of the earlier builds it could have been. So we'll open up the firewall here. And what I need to do now is to go and do two things. Firstly, to get DCOM working through the Windows firewall, I need to open up the RPC port. So I have an entry here where I've gone and said, okay, the port is 135, it's RPC. So I'm going to click on that, click OK, and, oh, damn, I forgot to do the other thing. The way DCOM works, you know, a lot of developers use DCOM but don't really know some of the intricacies of it. But for the point about how it works for the firewall is the initial connection comes through, and you can imagine, you know, in the simplified sense, I call through port 135 to DCOM to say instantiate my object, but I'm talking to the DCOM subsystem at that point. When my object gets instantiated and the pointers are handed back to me to manipulate, I now actually talk direct to that process. So the next thing I need to do to turn the firewall on is actually go into the exception list and add my DCOM server to that process. So I'm going to click on OK, click on OK, and now we're ready to go and talk to that system again. So let me close that, bring this back up so you can see the process list. Close that. And we'll go back to this machine here. What I'm going to do is drag the pointer back up here. Just set the point of debugging, and we'll run this again. And if you notice, everyone can see this, I'll change over. The error has changed from an RPC error to an e-access denied. So we're now talking to DCOM. Now we're checking the security preferences. We're now saying, can I instantiate that? Am I allowed to talk to that object? So yes, I am. So what I'm going to do now is go in and show you how you set the security privileges on that object. In DCOM, you run the DCOM config utility. It's just the component services utility. And you need to make a couple of settings. First of all, go into My Computer, and you can select the COM Security tab. And what you get is access and launch activation permissions. You have default permissions, and you also have this concept of edit limits. The limits are effectively the gatekeeper for the machine. So what I'm going to go do is go into the limits, and I'm going to add the anonymous user to those limits. So I'm going to say an anonymous user coming in is going to be able to do remote access. And we'll do the same thing for launch and activation. And we'll tell it that it can do all the access that we need to. So that's all we need to do for the limits. Now I want to go into the specific component that you're running. Now you could make these changes in the default system-wide settings, but you shouldn't do that. The reason is that by default, if you make those changes in the default system, you open up every server then to be accessed by that anonymous user or by that guest user. You really should go in and set the limits, which says what people can pass through the gate, then set the individual security permissions on individual objects. The first thing you need to do is, because we're doing this by anonymous login, we have no authentication, so we'll turn that off. The next thing we want to do is go in and set some custom launch and activation. One of the things that we did in SP1 and earlier, launch and activation were effectively the same thing. So a user could call in remotely and have a component start. What we realized was that was not necessarily something you as developers would want to have happen. You might want to have an object only available for use once a user has specifically launched that object. So we now split the access and activation, launch and activation privileges up. So I'm going to add the anonymous user in here again. And we'll spell this correctly so it works. And we'll give it our privileges. And we'll do the same thing for access. Now, strictly, you have when you have self-specified, what self says is basically this object should be able to access itself. So you really shouldn't need to add the anonymous login here, but what you can do is you might want to turn off local access to, say, stop it from being able to run stuff locally. The last thing you need to do is, if I was to try and run this now, the identity, the process that it runs in, is going to be launching user, which would be, because we've made all the ACL settings, the anonymous user as we go through. So what we want to actually do is go in and say, okay, that's not who we want to run. We could set a particular user. I'm just going to select the interactive user, and we'll click on OK, and let's bring that process guide up. And let me go back to our source code on the right-hand screen here. And now we'll step through that again. And what you'll see over here is you'll see the DCOM server will come up in the list as we now start talking to it. We're instantiating it. Back here, if you look at the return code, you'll see that we get back and everything works, SOK return code. And now I can step through this. I can call functions. I'm going to set the name on my component. I'm going to get some sayings on there. I'm going to have a look and say, okay, I'm calling the function. You can see the code I'm calling. I'm calling the DCOM server on this VPC over here, and it's going and getting me the name of that machine and returning that to me. So very quickly, what I just showed you there, would you like edit and continue to apply your code changes? No? Okay. What I showed you there was just simply how to set up DCOM, and you go through that exact same process if you were setting up DCOM for an authenticated use. You go and set it in the limits, you set it for the user, and you move on forward. So let's actually now just go back to our slides and continue on with the next major bucket of changes. This is the email instant messaging attachments. One of the goals that we wanted to do here was to provide a consistent user interface for users. We wanted to make it simple for them to look at a trust decision and decide what they should do about it. You could imagine the case of two applications. The app here, I've written this app and I know I never get bad content, but I want to give the user the option of whether to run that or not. So when a user double clicks on some content, I throw up just a little dialog box that says, would you like to run this? Yes, no. On this other application, I'm like, oh, I can get some bad content here. So I create a user interface that when a user double clicks on this, I present a dialog box that lists everything that can go wrong. It'll take over your machine, it will cause your hair to fall out, it'll cause the heat death of the universe to occur. Don't run this code. Now, what I teach the user is not to think about how I make a trust decision on the content that's coming in. What I've just taught them is that a small dialog box is perfectly safe. A large dialog box is something you never want to see. So they'll click no here and yes here. We're not leveraging the ability of the user's consistent experience in the Windows environment in making trust decisions, in letting them make a trust decision about things that are occurring in our application. So what we wanted to do was to provide this consistent way of having the user have this consistent learned trust response. And to do that, what we've done is create the Attachment Manager APIs. This is a new API called the iAttachment Execute interface, and it has a series of methods on it that enable you to do things such as check the policy. Do I want to launch these components? Do I want to launch this dialog? Present a consistent UI to the customer so they can make decisions. We also have made changes not only in that interface, but we've also done things such as go through our code. Outlook, Outlook Express, Windows Messenger, MSN Messenger, Internet Explorer. From SP2 on, we'll make use of this consistent UI. From a developer perspective, the benefit is that I get all this UI and I get all this policy checking and I don't have to write the code. I can just call a very simple API set. We've also done some work in terms of message preview. We've turned off some of the decorated URL exploits that spammers can do to try and work out whether or not your email address is valid by presenting you HTML content that'll call home. They'll go in and have a bit of script or a bit of JavaScript that'll run in an HTML message. We'll go contact a server and basically flag that somebody is looking at this email address. Effectively, all this stuff replaces association is safe, so you can make a decision prior to executing something. Developers should simply go and use this API. Your call to action, if you get binary content or content you want to execute from an external source, use these APIs. It doesn't have to be an attachment. It doesn't have to be email. It's a slab of binary data. You can create a file and use this information about the file prior to execution. So let's have a very quick demo of what goes on in that particular case. So I'm just going to close this solution down. And I'm going to open up this... Oops, sorry, I'm on the wrong machine. Let's go to here. We'll go back here. So I'm just going to close this down and go here. So what I have here is a very simple app that basically goes through, and what it's going to do, let me just move to the top of that. I've got some attachments. I'm going to go check my policy. I'm going to see whether or not I can do things with it. Then I'm going to go and execute some stuff. So let's run that. Yes, we want to build it. All this code is actually available. You can go to msdn.microsoft.com/security, and this demo code will be up there. You can also go to my website, blogs.tonygoodhew.com/xpsp2, and this content will be there as well. So basically, I'm going to go call some API. I'm instantiating that interface. I'm going to get access to it so I can go and do these policy calls. And so the first thing I'm going to go do is I'm going to say, okay, I've got a file name. You know, I've got a JPEG file. I want to actually go and call that and see whether or not I should be able to do something with it. So let's actually jump into that call. And you can see it's very, very simple. Basically, all I do is I say, hey, I have this thing and it's called this file name. Can I really do something with this? Am I allowed to save it, execute it, run it? And so if we just step through that code, right, so let's, this is somewhat slow, but we'll go to a breakpoint and then we'll actually just run through. What I want to show you is the return code. In this particular case, the return code's come back and said it's SOK. It's okay for me to do something with that. So let's run to the next point that I wanted to show. Now I have another bit of content. You know, the first was a JPEG, so I was allowed to manipulate that. Second bit of content I have is a little executable file called dialog.exe. You know, you've sent me this slab of binary data. It's an executable. Can I run this? So let's actually just run that code through a bit further. And what we'll actually get is the same code was called, and now you can see the error message we get is e-access denied. So the system is coming back and saying, no, the settings you've got currently, the zone that you're telling me to check the policy for, there's no way you can run an exe from this particular zone. So now that I've gone and done that, and I could check the policy, now I want to actually do something with it. In this particular case, I'm going to go and execute my JPEG. And so if we step into that code, you can see the code that we're calling here is very simple. It's a similar same thing. It's the interface. We're saying execute this. One of the biggest problems that people make in Windows in calling the Win32 API is to grab some arbitrary file and call shell execute and tell the shell to go and execute something. Well, as soon as you do that, you're just executing arbitrary code. There's no security checking behind it. With the execute method on the attachment manager APIs, what we do now is check policy. We make decisions as to what we're going to do as part of that execution phase. In fact, if you'd actually saved the file, you get the slab of binary data, you check the policy as to whether or not you can save it. When you save that file, you use the save file method. What we actually do is we serialize the evidence that we would use to make our policy decision into that saved file. The aim of this is to work around, the smart user that's got the Anna Kournikova image that you won't let them run and says, I'll save it as a file to my disk. Then I'll go later on and I'll use the Explorer and I'll execute it. Well, Explorer will use the same execute methodology to go and execute the file. So it will go and extract the evidence from the file and go, no, you've still downloaded this from the web. The fact that you saved it doesn't allow you to go and execute it. So let's run that code. Oops. We've gone all the way through to execute. We're allowed to go do that. So if we run that code through, you'll see that we've actually gone through, we've executed our JPEG, everything works successfully, we're opening up our image, number 2 in the NFC according to the ESPN Power Rankings. And we now move on to our next one. So we've executed the JPEG without a problem. Let's now go and try that same thing against the dialog.exe. So now I'm going to run that, and when I call the execute method, what it's doing is saying, no, hang on, this is an executable. You can't run this. Windows has blocked access. And you can see that I've got now some information. I can click on that. As far as the user goes, I get this dialog all the time. I get the same help file information will come up explaining to me what the reasons are for why I can't run this. Yeah. Right, so the question is it actually checking the file? In this particular case, the file, because I'm not going through the task of actually downloading something, what I've done is I've actually put the file in the same directory as the demo code. When I call execute, what it does is it looks at the file name, it looks at the evidence in the file. Now, there's no evidence in the file because I didn't download it from anywhere, I didn't get anything to save it. Right, when you go and try and change the file name to that, from a .text to a .exe, you still have the evidence about where it was downloaded. So the execute would then go and look at that evidence and say, no, I'm not letting you go and run that.
Where does that information live?
So it's serialized into the file itself. I don't know where in the file it's serialized. So it could be in the file header or it could be tacked onto the end of the file. But it's serialized somewhere in the set of bits that is on the disk. So if we click on OK there, we can come back and you can see the error we get is access denied. So very quickly what I did is I just showed you there how we can run we can utilize the APIs from the attachment manager interface to go and make trust decisions. And we'll actually also present that standard UI, those same questions, the dialog box, the prompts, all that sort of stuff to the user based on the simple API calls that we get from that particular service. So let's go back to our slides.
Does this mean that you compare two binaries? One that I download and one that you download are going to be different?
Depending upon what our zone security settings were. So the question is, if we both download the same binary, are they different? If you download them, use these APIs to serialize them to disk, they will be binarily. Binarily? Sure, it's English. Australians have a very tenuous grasp on the English language to start with. They should be different because you may have them from different security zones. You may have the site in your trusted sites. I may have it just in the internet zone or in the restricted zone. So the actual evidence that's serialized with that binary file will be different. Yes. Yeah. Yeah.
Is there an effect on older versions of Windows?
So the question is, does it affect other systems? No. The information is maintained and worked on only by the attachment manager execute function. In fact, I'm pretty sure if you just went and called shell execute against it, it wouldn't read it either. I don't think we changed the code path for shell execute. What we've done is added the new execute method. So apps that call the execute method will immediately get that evidence-based execution policy. But if you call shell execute, it'll still run exactly the same way as it's done previously. So moving on, this is web browsing. We've looked at network, we've looked at email instant messaging. Now we have web browsing. We've done a ton of changes in terms of web browsing. And these are going to impact you if you build websites because your UI is going to be presented to customers in a different sense. Firstly, we're locking down the local machine and intranet zones. We're making them more restrictive. We used to give them very, very great powers. Now, local machine, we're not allowing you to run active content or scripts or so on because people have been using that to exploit machines. We're also changing the dialog boxes that you get. So when you go to a website, you can try and download code. You'll now get a more expressive dialog box that will say, here is the dangers with running this code. If you try and go to an HTML page that opens up an unknown or an unsigned ActiveX control, then we simply will not download that. We'll block it. We won't even give the user an option of installing it. It will be there. The user can go if they really want to. They can go and install that. but they won't be presented with a yes, no, run this. The reason that we're doing this is one of the most inventive attacks that I've seen, which is this site put a malicious piece of code up in this ActiveX control and presented a dialog box to the user. And when the user went to the web page, IE would present a dialog box to the user saying, this is an unknown, unsigned code, it's potentially dangerous, do you want to do this, blah, blah, blah. Telling the user, we recommend you click no. Then what this site did is fire up another copy of IE that actually had no borders, no windows, was the same color as the dialog box, and positioned it directly over the warning text, higher up in the Z order, and put text like, would you like to win $1 million on it. So the user was answering a dialog question from Windows as to whether or not they should run insecure code. But what they saw was text from this website saying, would you like to win $1 million? So of course users are clicking on the yes button when really they should be clicking on the no button. Now we're just simply not going to let you do that type of stuff. Additionally, we're changing the allowable amounts of Chrome that you have on a window. In that particular case, they were able to get away with it because there was no Chrome. Now there will be a status bar, a minimum of a status bar, that will tell the user that this content is coming from Internet Explorer rather than from Windows. So you'll start seeing that type of change. Moving on. One of the things we're doing is addressing some customer complaints. You go to some websites and they will, they're written on GeoCities and these guys want to make some money. So what they do is they bang you over the head with WeatherBug or Gator or local time, all these ActiveX controls that they want to install on your machine to help you keep the weather or your time up to date or something. When really what they're trying to do is to get spyware onto your machine. And you keep clicking no, and every page you hit, you've got to click no again and no again. Now what you'll be able to do is when you're prompted from IE, do you want to install the Gator Corporation ActiveX control? You can say no and never ask me again. So at that point, that control from that publisher with that digital signature will never ever be prompted for install on your machine again. Additionally, you won't be able to get pop-ups. There's now a pop-up blocker built into IE. So you can go in and say, I never want to see pop-ups from this particular site. One of the things that we do is also go and look at how the pop-up happens. So if you've built a site that uses a user interaction to display the pop-up, then we'll let that go because the user is asking for that information. You try and script pop-ups, no, we'll block those things. Finally, we're we've made a number of changes in terms of cross-domain scripting. User-initiated actions will allow you to change domains, from trusted zone to intranet to local machine and so on. Non-user interaction will not allow you to change domains. We will not allow you to get its own elevation through a scripted control. So what you need to do as developers is to think about what you've got in your application, how it interacts with IE. Run this and look at it. Do I use pop-ups? Do I use script a lot? Do I rely on this zone elevation? You should also, if you're an ActiveX control developer, go and check your controls and check that you haven't marked them as safe for scripting. We made this mistake ourselves in VS6. When we released VS6, we had a set of controls that we had never tested in a scripted environment, but we had had them marked safe for scripting. So at that point, what was happening is somebody could script those controls we'd never tested from a security standpoint. So if your controls aren't scriptable, or you haven't tested them, you haven't done that work, just simply mark them as unsafe for scripting. So let's jump over to the laptop, and I'll give you just a quick demo of some of the web changes. So here we go. We'll go over to the demo website. The first one is changing the dialog box look and feel. This is what you would normally see if you downloaded a file from the web using Internet Explorer today. This is what you get if you try and download the file now. Now you get a security warning, and you get information about, this is potentially harmful. What should I do? You've got this consistency of learning about whether or not a user should make a trust decision. If you want to write antivirus software or software to assist in this trust decision, there are a set of APIs that we have behind these warnings that can get fired off, so that what you can do is at the point this is fired off and said, hey, we're looking at this, or a user wants to download it, you can actually get invoked so that you can get involved in the download process, but still leverage the actual UI model that we're going to present to the user. So I'm going to cancel that. The next thing we've got is, I want to show you, is some of the changes to the local machine lockdown page. If you go to, and run a local machine page, in this particular case, this page is coming from my machine. I have a scripted event. I have this little dialog box that runs. And if we view the source for that page, you can see that it's just basically a little, where's body? It's a little on-load window alert. But if we go back here, some of the stuff that that we're restricting from the local machine zone are things like, client-side script. So you can't have a page download. Now you have script running. You can go and execute that automatically. ActiveX controls, running Java components, running any form of sort of unsigned ActiveX controls in that area. These are controlled by these keys, and you can affect them. But that web page you saw, there it goes, with the scripted event. Let me actually run the link to it on my machine. So let's show that a little bit better. Here's that page. I'm going to go click on that link. And this is the common UI that you'll see from SP2. This is this information bar that comes down and tells you as the user something has occurred. And it provides you with context and information that you should use to make your decision. So what I can do is right-click on that, and now the user can go through and allow my content or not. Now that same sort of concept applies to things like pop-ups. So for example, here's a page that I'm going to that's trying to launch a pop-up. We get a pop-up message, and if I click on that, it tells me that a pop-up window exists, and I can allow that to come up. That doesn't give it to me all the time. Next time I go visit that page, I still have to have that request. So that information bar is very common. If I go to a web page and it tries to push binary data down onto my machine, and typically you see that if you go to download.com or shareware.com, or you go to a website that's trying to get bits, you'll get that same information bar will come down. Some of the Windows UI restrictions, we have this concept of opening a window in the kiosk mode. So if we click on open window in the kiosk mode, you'll see that we're not allowing the window to be opened without title bar and status bar, so you can't spoof some of the UI model. And another thing that people did was try and run code and move the window off the screen. So what they wanted to do was to hide the title bar so you wouldn't see it. And then they'd expand the window so that you wouldn't see the status bar and try and confuse the user that this code isn't there. And if we have a look at this source, you can see that I'm just, actually, sorry, wrong page. Let me go back to this page here. If we have a look at the source here, what you can see is I'm trying to do just a very simple move command where I'm saying a bit of JavaScript, create the window, and then move it off the screen. Now for the internet zone, we won't let you do that in IE. So let's go back to our PowerPoint. We're rapidly approaching the end of the presentation. The last major area I wanted to talk about was data execution. Yeah?
How does this affect using the web browser control and application?
How does it affect using the web browser control and application? These will appear, this will affect using Shadok View in an application. I don't know if all of those things appear in that control. I think they do. If you go to msdn.microsoft.com/security, there's a link to a thing called the changes to APIs or changes to Windows XP SP2. Now, it may have been the one you looked at before. This is the latest version. This is 170 pages now of documentation about the changes. If you follow that link, it's May 24th or May 14th or something. It was in May of this year that it was published, so don't get the earlier one. Basically, there's a section there, I think it's chapter 5, on the changes in IE, and it will go through, and it goes through in excruciating detail, each of the individual changes that will appear. And I think all of these ones that I showed you will appear in Shadok View if you use it as a control, but that would be where to check to see exactly what appears there. Data execution prevention is about taking advantage of the latest underlying hardware in which to run applications. And what a lot of the manufacturers are doing, AMD started the rush with the Athlon 64 and their x86 architecture, 64-bit x86 architecture. They included this feature in the processor they call non-execute, or NX. What that enables you to do is to mark a page of memory as non-executable. So typically you would mark a page as non-executable, and then if you tried to set the CPU's instruction pointer to a memory location in that page, the CPU itself would throw a hardware exception saying, hey, can't run that. So then what would go on, then all the other manufacturers jumped on the bandwagon. Everyone's releasing this type of system. So it's very, very easy for you to actually go through and write an application that takes advantage of this stuff. And in fact, if we go to this machine here, I'm just going to open up the Data Execution Protection app. And what I've got here is a very simple application. I have a dummy function, and I run that dummy function, and it tries to copy the function across to a page that exists in my stack, which is by default a data page, and then I set the function pointer to it and I execute that function. If we were to go over here, you can have a look on this screen here. I'm just going to change to my VPC image. I have exactly the same code. If I go to that particular piece of code and run that code, in retrospect, I probably should have put a shortcut on the desktop. If I run that piece of code, it'll throw an error because this is actually the wrong version. But let's assume I ran this piece of code. We'll just close that down. That doesn't exist. It is dead to me. What it should have done is actually go and run that piece of. I made the changes to the source code on this machine, and I forgot to copy it across to my VPC image. I basically pass the reason it doesn't work is that I have it by default. You compile with an incremental compiler and use a DLL for the C runtime linkage. That won't work if you're trying to just copy a memory segment. You've got to do like the static non-incremental linking. You've got to link to a runtime library that appears in memory, or appears statically linked, so it's not a simple offset jump, or otherwise it actually just crashes. But that's the background reason. Trust me, it works. On this particular piece of code here, if I was to run this, I'd generate an error, and I can just double-click on this. I can show you. Oops. I can show it working perfectly. Let me go to the properties. I was demoing this a little earlier. This is a tab called Data Execution Prevention. And I'm just going to turn that off, and I'm going to run this app again. Now we're trying to execute that code out of a data segment, and so what you'll see is this could be a buffer overrun. Somebody has spoofed my app past a heap of code, and now I'm trying to execute it. So we'll actually throw up a piece of UI that says to the user, hey, we've tried to execute this. This is bad. It won't run. Unless you particularly want to enable it to run. And so you can select that you do not want to use data execution prevention for that application and run the app again. And now it actually works perfectly. We're not enabling NX exceptions in that piece of code. So this gives you a way of utilizing the underlying system hardware itself to protect you from malicious code that executes buffer overruns. So let's move on. So what should you do as developers right now? Well, right now, as in the next immediate 4 days, you should go to Dev 370 and get the extra information that that session will have. It'll have a more in-depth walkthrough each of these areas, showing you the code, showing you the APIs. The point of this session was to be a bit of an overview and show you some of the features and exercise some of the functionality. What you should do when you get back from TechEd is, or in fact, go to the TechEd store and buy Michael Howard's book on writing secure code. One of the problems with security is as the underlying layers in this stack diagram get more and more secure, people are going to start shifting their focus of attack from the OS to the Microsoft app software, to eventually to your software as you go up. And so, in the future, your apps are going to be under attack. And you've got a bit of lead time now to start thinking about writing secure code. Go take your apps today, go to one of your test machines and turn the internet connection firewall on. Just with SP1. Turn that on, run your test scripts again, does your app work? If it does, most likely, 90% chance your app will have no problems in SP2. But to make sure, you should go and get the release candidates of SP2, of Service 2, from MSDN. So go to msdn.microsoft.com/security, grab those release candidates, put them on your machine, and run those and test those against your applications. In the immediate future, you should go out and buy yourself like an Athlon 64 or a new Transmeta or Intel chip machine or something like that, and get at least one for your test lab. No need to replace every dev's machine in your business, but get at least one and test your apps against it. All of the major hardware OEMs are all moving towards pushing their mid-range and upper-range machines to be these 64-bit machines. So your customers are going to have these as desktops. They are going to be running SP2. We're going to spend upwards of $300 million in communicating SP2 and getting SP2 into the retail channel, into OEM and corporate customer hands. So it's going to run, and it's going to run on the 64-bit machines. Do the work now to test to see whether or not your app runs successfully. If you need any information at all, the place to go to get it is msdn.microsoft.com/security. Go there, you can get the platform SDK release, RC1. You can get the RC1 bits. You can get the sample code from this presentation. You can listen to webcasts, white papers. You can do developer training. It's a 90-minute training course that will walk you through a lot of these changes. You can get the Windows client-side IT Pro information. How am I going to deploy this? What is this going to do with SMS and things like that? It is really the place to go to. So that's the end of my session. For some reason, I'm not taking slides. I have some time, I think, for some questions. What time is this session supposed to finish? 4:30? Let me just check. Yeah, I think I'm actually over time. It's 4:31. However, I'll hang around while I shut down. I'm happy to take questions. Please fill out your evals. Go to Dev 370. Go to MSDN Security. If you need to, if you guys have questions, you want to contact me, don't use Rio. I'm never going to read it. Send it to tgoodhew@microsoft.com. tgoodhew@microsoft.com. For some reason, however they have this set up, doesn't want to go to the front slide. But it's tgoodhew@microsoft.com. I'm more than happy to take any questions that you may have. Thank you very much. Enjoy the rest of Tech.